Hello, everyone. Thanks for joining us. I'm Mark Songini, Content Marketing Manager at Triumvirate Environmental, and I have the privilege of being your moderator today. I'm excited to launch our webinar, the New Jersey Department of Environmental Protection Air Monitoring for Engineers, What You Need to Do. But before introducing the speaker and diving into our informative event, I need to perform a bit of housekeeping. First, everyone's microphones will be off for the entire webinar. If you have a question, and we do welcome them, please use the questions tab in your webinar panel. It's to the right of your screen. Second, there will be live polls throughout the presentation. We encourage you to participate in them so we can get to know you and your needs better. Finally, please remember you will receive a copy of the slide deck and recording following the webinar's conclusion. It's now my privilege to introduce today's speaker, Matt Decker. Matt is an environmental health and safety consulting account manager for Triumvirate Environmental. He has more than 15 years of experience with perimeter air monitoring systems and equipment. In his current role, he works closely with consulting engineering firms, construction companies, and developers to ensure their projects operate efficiently and meet project compliance goals. In today's webinar, Matt will discuss the changes that have been occurring in New Jersey's environmental monitoring and enforcement landscape. And with that, welcome, Matt.
Thank you, Mark. That was a very nice introduction. I appreciate it. I also appreciate everybody that's jumped on and taking part in this webinar. As Mark mentioned, we will be reviewing the newest guidance document and giving you a bit of a summary as to what our interpretation is of what the DEP has put out. A little bit about today's agenda. We're going to cover the history of air monitoring. What is PAM? When do you need it? The DEP requirements for air monitoring, the types of monitors that you will be using, sampling techniques and methodology, key takeaways, as well as the triumvirate services that can help with these services and requirements, as well as a question and answer segment. A little bit about the history of air monitoring. This goes back, we were doing air monitoring probably 20 years ago on a project that was heavily contaminated with hex chrome. We were brought on to do all of the perimeter monitoring, and at the time it was very analytical heavy, not so much with real-time monitoring. We had stations set up at the perimeter that would data log all of the data at each instrument and at each location. At the end of the day, the technician would have to download that data and compile a report. They also would spend rounds throughout the day taking readings at each one of these sampling locations and making notes in a field book. This proved to be a little bit counterproductive because you could be all the way across the site and getting a reading at the opposite end of the project, and you wouldn't know that there were elevated readings until the very end of the day. This proved to be very reactive rather than proactive. Mark is going to step in and we have our first poll question.
Thank you, Matt. And the first question is, are you working on or planning a project impacted by the new guidance? And the responses are currently working on a project, planning a project, no immediate affected project plans. And I will now launch the poll. And we'll keep it open so that the audience can offer its input. Getting very good response. And we'll leave it open for a few seconds more. A very pertinent question, clearly, given the response rates. And I think that we have hit saturation. So I'm going to close the poll and I will share the results. So the answers are currently working on a project, 29%. And in the lead, planning a project at 38%. And no immediate affected project plans was 33%. And perhaps, Matt, because you're the expert, you may have some comment on this poll and the results.
Now, this is great. I appreciate the poll. Everybody participating is great. The planning a project, hopefully during this webinar, we answer some of your questions and maybe can even offer some support down the road. Collecting all this data is really what this PAM project is all about. We're collecting real-time data now for these contaminated sites. And this poll is a great example of us collecting some of that data. Okay, what is PAM and why do we need it? PAM is short for perimeter air monitoring. It consists of real-time monitoring of contaminants of concern to manage site activities to protect off-site receptors. Our biggest goal here is to not impact the surrounding areas of these contaminated sites and ensuring that any sort of airborne issues are kept on site. This isn't really a new idea. This dates back to May of 2012, and it's part of the technical requirements for site remediation. The new document, though, lays out a little bit more as to when and how the PAM should be implemented, really moving to a real-time monitoring focus. A little bit more about the guidance document. This has been in the works, I feel like dating back to probably 2021, pre-COVID, and I know it hit some delays in the release date, but it finally was released in early December, with enforcement kicking off 6 months after that, which puts it around early June. The DEP created this with its own workers, along with some stakeholders that would be involved. Triumvirate ourselves, we had 2 staff members that were heavily involved with the development of the plan. Deb Barsati, who's a toxicologist, and then Bruce Groves, who's a certified industrial hygienist. Both of them sat on the committee and helped develop this plan. Some of the key parts are, you're always looking to measure upwind and downwind at a minimum. So you would need 2 real-time monitoring stations, and you're going to be measuring most likely non-specific contaminants, either with PM10 for particulates or TVOCs for vapors. And you're really just capturing the surrogates. You're not getting the specific chemicals that are on the site. Another critical piece of this is a meteorological station. You really need to learn and figure out where your elevated readings are coming from, and that wind speed and wind direction are a critical part in terms of figuring out where the source of the elevated reading is coming from. Confirmatory sampling is really there to measure the effectiveness of your real-time reading. You're going to need to start collecting laboratory analyticals, send them out, and get those results back to pretty much show that your readings in your real-time stations are below the response levels on site. For us, after reading this, we would recommend using a telemetry network-based system. At this point in time, in 2024, we've come a long way with these systems, and there are a few out there that will provide this information to you in real time. You don't need to sit there and walk around and have those technicians taking readings and missing alarms. The newer technology will provide real-time alerts via text messages or emails, and they're also going to generate a nice daily report that you will need to submit at the project completion or daily, perhaps, to the stakeholders. The guidance document also spells out that the plans need to be followed during all remedial activities. They mentioned trenching, any sort of excavation and disturbances of soil on these known contaminated sites. When do we need to implement it? The guidance document clearly states that any project that is greater than 20 days in a 30-day period must have perimeter air monitoring on site. Now, there's a line that follows it in the guidance document that says activities with the potential to generate emissions that may impact offsite receptors should also have PAM in place. Now, my interpretation of this is if you're digging in a heavily contaminated area, but you know you're maybe doing some short-term test pits, maybe a week's worth of test pitting. Obviously, you don't hit that 20 working days, but it's always best to have that data to show that you're not exposing any of the offsite receptors to these elevated readings. Deploying PAM as part of this guidance document, they recommend that all of the projects that have PAM implemented have a designated perimeter air monitoring technician. In the past, there was a lot of opportunities and times where consultants would have somebody that was on site doing soil sampling or various other tasks, and they would often set up the stations and then get on to other tasks throughout their day. At this point, the guidance document recommends that the PAM technician is dedicated to this. They handle all the analytical sampling. They could really stay on top of it. The guidance document also recommends real-time monitoring with data logging devices, whether that be chemically specific as a GC perhaps, or a H2S meter, or a surrogate. Again, is your instruments that are going to pick up PM10 or TVOCs. They're not going to tell you exactly what's in the sample, but they're going to tell you have some number in there. Confirmatory analytical sampling is required with all of these deployments. Again, you want to make sure that your real-time sampling is actually effective in its use. The PAM recommends a background study prior to any work happening on site. I'll cover this a little bit later, but it's always great to know what your ambient air quality is. Oftentimes these project sites are in pretty urban areas with a lot of activity around. So you want to know just what your general air quality is. The best practices obviously are always recommended to minimize your air emissions. That would really involve your engineering controls, whether it's using spray foam to keep vapors and odors down, or water trucks. We see a lot of water trucks on these large remediation projects. Obviously the water will knock down any dust particulates that would be traveling off site. The other thing too is, tarping piles, stockpiles, either if, at the end of the work day, or if you're not going to be using them, if you don't need to access them, cover them up, have them tarped, and you should be fine. The other big part of this new PAM guidance document is attention to the documentation of all of the program, along with a QA/QC. Obviously, quality assurance, you want to make sure you're using the proper instruments for what you're actually trying to capture. The PAM development plan, this is laid out in a nice chart here. The guidance document also breaks it down into these 7 steps. I will be going through all 7 of these steps, but I will really be focusing on steps 4 through 7. in this presentation. The DEP ran a summary and broke down the plan themselves, the guidance document, and they did it over a 2-day period, 3 hours each. With our limited time, I'm really going to focus on those 4 through 7 steps. Step 1 is identifying contaminants of concern. Obviously, these are already sites that we know have some contaminants in the soil, water, and during your phase 2 analysis, phase 1 analysis, you have an idea of what these sites were. And then during your geoprobe, you've collected soil, water data, so you know exactly what you're working with and what you have to deal with. So your volatile organics would be your benzene, TCE, semi-volatile organics, PAHs, PCBs, naphthalene obviously being pretty common, particulates for PM10. The guidance document references asbestos for PM10. I know for us, we've traditionally always done analytical sampling for asbestos, but if you can use a particulate monitor to capture asbestos readings, I believe the level they give is 150 micrograms, and as long as you're below that, you should not be exposing anyone to asbestos. I would assume confirmatory sampling, it should go along with it. Odor-causing compounds, H2S. This one is kind of near and dear to my heart. We've been brought in on a couple of sites at this point where a project had some neighbors that were complaining of that rotten egg smell that were surrounded by that were surrounding a landfill. We ended up going in and setting up multiple stations around these landfills. It oftentimes in the backyards of some of these residents, trying to get as far away from the landfill as possible, but really trying to capture what the people are being exposed to. So we're able to capture those readings and give them real-time readings as to what their H2S levels are at their location. We're able to send alerts and make sure that the public isn't being exposed to anything that would be harmful to them. And then other common compounds that we see are mercury vapors as well. So step 1 is identifying those contaminants. Step 2 is your conceptual site model. So this is, you're really looking for your route of exposure. Very typically, it's going to be through inhalation. You can see over here on the right-hand side, this is a generic model of a conceptual site model that shows with the contamination in the ground and how it's affecting the people that are around the project site. The other part of step 3 is establishing a new term. It's called these health-based threshold values and the response levels. So part of the DEP guidance document, they've put together a PAM calculator. There's a link to it here. I believe you can get to it also directly from their website. And what you do is you take the list of chemicals of concern that you have in your data, you enter them into this calculator, factoring in the duration of the workday and estimated duration of the project, and it will give you these values. So the response level is for non-contaminant specific, and that's the level you're going to set for your instrumentation or your real-time stations. That's the level that you're not to exceed. And then the health-based threshold is contaminant specific, and it's based on a 15-minute time weighted average. Typically for these levels, you will be measuring the surrogate using PM10 or VOCs, unless there is a contaminant specific instrument that you can use. Also, if you're measuring a contaminant specific instrument, you have to do no analytical sampling because you're actually monitoring for that specific chemical. Step 4, identifying air monitoring methods and technologies. So the PAM program uses a combination of the real-time instruments and periodic confirmatory sampling. The real-time equipment is always to be equipped with data logging. And like I said, I would recommend using a wireless system that's out there to transfer that data. It allows people to view the data in real time. It allows them to respond to these higher levels of readings that you may come across, and then to act on them prior to any sort of response levels being needed. You're capturing the surrogates of the air quality, unless obviously you have that specific instrument. You're also doing the confirmatory sampling to demonstrate that the real-time monitoring is working properly, trying to keep it below those response levels and health-based threshold levels. And the last point here, again, should have a dedicated air monitoring technician on site operating the system day to day. So here the intended use is to control emissions to impacted to off-site receptors. The HBTV levels are for contaminant-specific instruments, as we mentioned, providing real-time readings. Again, those are your GCs, your H2S meters, mercury meters, whereas your response levels are using instrumentation that just captures a surrogate of that contaminant of concern. The way that the stations would be set up, there's a couple of different ways. There's stationary stations that would be set up at fixed locations around the perimeter of the site, oftentimes between the work zone and the off-site receptors, but mounted to site fencing and telephone poles maybe at the perimeter. We often see these for larger sites that have a longer duration, not typically your shorter term projects, but they can be used in any shorter term project as long as you know the stations may not need to be moved. They're often in lockable enclosures because the equipment is left out. You're not bringing in the devices daily. You're going to leave them out there for the duration of the project. And these stations would be powered either by AC power that's dedicated and dropped for the project, battery power here with DC, or another good option is solar. Although Jersey, we do have some rough winters here, so the solar is sometimes a little bit finicky, but it's a pretty good option also for your fixed stations. The mobile stations are a very common application for these. The mobile stations are often set up daily. They will break them down at the end of the day and stored on site. But they also can be moved from work zone to work zone. But you always want to set them up in between the work zone and your off-site receptors. These would be instances when if you have two stations, more than likely you have two mobiles, so you can adjust them with your wind speed and direction readings. More often than not, these stations too are powered by DC batteries or small solar cells as well. Your meteorological stations, these like I said earlier on, super important. It's critical to know what your wind speed and your wind direction are doing on site. These instruments will be in a fixed location, and we would recommend always putting them in a fixed location, not putting them with a mobile station, just for reliability and accuracy. A lot of these instruments, like the ones at the bottom, you have to face the instrument north to get accurate readings. If you're setting it up every day, there is a chance that it might not end up, getting you the most accurate information. But having a larger site, you may end up using multiple. In the bottom picture, that taller one will give you wind speed, direction, temperature, humidity, all of those factors. And then the little ones, they just give you wind speed and direction. So if you've got a large enough site, you might want to set up multiple meteorological meters here. Handheld instruments. These are to be used as supplements to the stationary or mobile stations. They're very commonly used on these sites, and they're really there just to do spot checks very often. They do have data logging, and you may be able to pull the data off of them, but they sometimes are very specific. So some of these instruments in here are, mercury meters or benzene detectors, but a few of them are just for particulates or VOCs. You want to make sure that all of your instruments, though, meet your data quality objectives, that they can be field calibrated with a zero cal or a bump test, or an infield calibration as well. These instruments are not to be used as your primary devices. You should have stationary or mobile devices. These would just be a handheld for confirmatory readings, maybe in between where you have your station set up. All right, Mark, we're on to poll number 2.
Excellent. Thank you, Matt. Great presentation so far. And our next poll question is, my biggest concern with the new guidance document is A, the creation and or development of the PAM, B, calculating HBTV and response levels, C, selecting the correct analytical method, and D, understanding and staffing the PAM stations. I'm going to launch the poll. And again, we encourage everyone in the audience to share your opinions. It helps us to understand your needs better. And we're getting a nice response rate. Obviously, a very pertinent and timely question. I'm going to hold it open a few moments more. Getting really strong responses. Very appreciated. And I think we're just about at saturation. Just a few more seconds, so please, if you're going to vote, vote now. All right, I think that should do it. I'm closing it, and I'm going to share the results. Okay, so number 1 response rate, calculating HBTV and response levels, 53%. The next was selecting the correct analytical method at 21% as the biggest concern. The third biggest concern was understanding and staffing the PAM stations at 16%. And the final response was the creation and development of the PAM at 11%. So once again, Matt, you're the expert. Maybe you have some opinions on this response.
Yeah, thank you everybody for participating in that. The calculating the HBTV and response levels, it is going to be something that's going to take some time. We here at Triumvirate have the ability to help you with that. And if you have projects or things that are coming up that we can help with, we'd be happy to connect and take it offline and see where we can step in and help. All right. Okay, getting back into it, we have confirmatory sampling. This is all part of step 4. Again, this is to verify that your real-time readings are effective. and at keeping the contaminants of concern below those health-based threshold values. It's recommended in the guidance document that sampling take place 3 consecutive days prior to the intrusive work, and then periodically afterwards. They reduce it down to weekly sampling. It's recommended too that after there are some changes in work or changes in operational hours, or if you're working now in hotspots, that you step that sampling back up and ramp it back up. If you know you're going to be in these areas, or if some significant change happened, you should be able to start collecting those analytical samples more regularly. The sample should always run for the full day. You want to make sure that it's based on that estimated workday, typically 8 hours or 10 hours, whatever you guys plan on doing on these sites. And it must be used, and you must use an approved lab method that's either EPA, NIOSH, OSHA. The NJDEP also has their own approved lab methods. And you obviously have to use a lab that meets these criteria. Identifying monitoring locations. This is step 5. As I mentioned, you always want to be putting the air monitoring stations between the work zone and the public, not right on top of the work zone, but you want to try to get them as far away from the work as you can, but within the property lines. The stations should always be placed upwind and downwind. If you have only 2 stations, you may need to move them throughout the workday. You may set them up in the morning, and then the wind may shift throughout the workday, and you may have to move each of those locations. Oftentimes, we will set up 4 stations on some of these larger sites and cover all 4 cardinal directions. That will allow you to have 1 upwind and at least all of the time. You really want vulnerable offsite receptors, being hospitals, nursing homes, schools, and daycares. Think of the people that would be most impacted by inhalation of these contaminants that are on site. And then also, when you're working in hotspots, you may want to focus more of your air monitoring in those areas, kind of drawing them in to make sure that you're really covering those areas where you know you have elevated levels. Oh, sorry, went one too far previous. Okay, identifying the locations again. You're going to run all of your PAM stations throughout your workday during all remedial activities. So if you, you're not going to shut them off during lunch breaks and things like that. But typically the way we've always done them is you set them up 30 minutes before the start of the workday, let them run the entire duration of the day, and then break them down after work has been completed. So typically the PAM on an 8-hour workday often will run for 9 hours. The analyticals, when you run your analyticals, you should always try to set them up at the downwind station at that location. So you want to run it not at your upwind coming from offsite, but from your downwind that's actually coming from the site. Your sampling frequency, as I said, it'll start out, it's recommended that you do the first 3 days, but then it can reduce as long as you are showing that you're below those response and HBTV levels. Turnaround time for your lab analysis, you may have to increase your turnaround time. If you're working in a hotspot, you might not be able to do a 2-week turnaround. You want to know more quickly what those samples read and what your results were. So you may have to increase your turnaround time at the lab. Obviously, you can get all the way down to a 24-hour turn for your lab analysis. Background sampling. So this is going to take place prior to any work happening on site. Before you even get a shovel in the ground, before you've got machinery on site, you really want to focus on getting what your ambient air quality is. And again, we recommend always with 2 stations, one upwind, one downwind. There may be evidence that shows that your upwind station is higher than your downwind station, just from some offsite source. And that's not anything you can really focus on, but you can alert the DEP if you do have some elevated readings offsite. Maybe you're next to a recycling center or some other manufacturing facility. You're really here to make sure that this background too is run for your 8-hour work shift, along with any confirmatory sampling during your background. You really want to mimic the work day that you're involved in. Step 6 is actions to address exceedances to the response levels. What you need to have is always a game plan as to what to do if you do get to those response levels on site. You can't just play it by ear. Part of the PAM development is coming up with these ideas and plans to put into place based on your 15-minute time-weighted averages. The DEP guidance document actually lays out some nice steps that you can use. They do a 4-level response based on every 15 minutes. So that level 1 15-minute time-weighted average gets triggered. You go out and just visually observe what's happening. Observe what's happening at the work. Are they actually doing work near the station that's getting the elevated readings? Check the instruments to make sure that they're functioning properly. And then again, check the wind and make sure that the wind is coming and blowing towards that station that's reading an elevated reading. Level 2 continues on for 30 minutes now. You need to get out your engineering controls. Spray the things down with your water trucks, get your foam out there to get your VOC readings down, and cover any piles, as we mentioned. So this is if it hits that 30-minute mark. Now, if you get to 45 minutes, level 3, you should take a confirmatory sample downwind of the work at this station that's getting your elevated reading. It's recommended to do a 1-hour sample at this location. If you continue to get it for 1 hour straight, you need to stop work. You need to reassess the whole process, see what's going on, continue watering things down on site, but you also, need to stop and kind of figure out how we can do this without causing these impacts to the offsite receptors. This is part of step 6 too. Exceedances not caused by the remedial work. You want to always document what's happening and what actions are being taken. This goes for your on-site exceedances, exceedances of the response level, as well as from off-site receptors. You always need to document what's happening and what actions were taken, whether the water truck was deployed or whatever the case may be. If it's a faulty instrument that caused it, take it out of service and get something else in there as soon as you can. I would say probably no longer than the next work day. This does happen though. We see a lot of off-site causes for elevated readings. Again, that street sweeper, that happened. We see that quite a bit around these construction sites. Plan modification, review, and documentation is step 7. This document is actually essentially a living document. You're going to need to reference it throughout your entire project. You're going to go back and make sure that you're following all of the parts correctly. And it's really there to make sure that it's being effective and that you're really not exposing any of your offsite receptors. Modifications to the plan need to be documented. We'll get into that a little bit more. Keeping records of all air monitoring reports and chains of custody. So that goes back to your real-time monitoring and your analytical data. Those are your chains of custody. Here I note here that you need to document all exceedances and the actions taken. You also need to keep track of all of your equipment calibration records. So any of these instruments that you're using typically will have some sort of factory calibration, and or they'll also have some field calibrations that need to be kept track of. I believe in the guidance document, it gives you like a sheet that you can use as a template. So a revised plan that needs to be adjusted is and reviewed is if there are adjustments to the HBTV levels that make it more stringent. So if you get to a point where you need to modify that, it really needs to go back for review. Significant adjustments to the hours of work or the activities that's going to happen. So potentially if you're going to be working inside of a tent, if they change the scope and now you're going to do something like that, those would need to be adjusted and reviewed again. Or if there's a change in the contaminants, you did your study, but you've come across something else, that is another reason why you would have to have it reviewed and approved before we move forward. The big push here for step 7 is the final report. Obviously, you want to be able to compile all of the data you've collected throughout this entire process and put it all into a nice, neat, simple report that can be submitted. You want to mention the contaminants that have been monitored, the response levels and the HBTV levels. A big part of it should be the site map showing locations of the stations and the receptors. I know for us, we've often laid a grid, like an ABC 1, 2, 3 grid over top of one of these site maps. And it allows us to go and reference those quadrants that will never change. A lot of the times we've seen in the past, and we've kind of learned that if you reference, that the station is set up by the main gate, that main gate may change as the project moves on. But if you say it's in cell D2, D2 isn't going to change. You need in your final report to explain all of your exceedances and what was done to resolve them. You also need to compile all of your data deliverables, data files from all of the stations, your meteorological station, along with the daily wind rows. I believe a lot of the systems that are out there now that you can use for this provide all of that data. You also need all your calibration records, like we said, chains of custody, and field notes. Obviously, while you're out there, you're still keeping these field notes as to what's happening on site day to day. So that should all be submitted to with your final report. All right, we have some key takeaways. So obviously I spoke here for 40 minutes or so. What we really want to learn from this is that your real-time monitoring of contaminants of concern are to manage your site activities to impact off-site receptors, keeping the surrounding community safe from what's happening on these sites. The activities that trigger this are 20 working days in a 30-day period. Now, we've had some people ask about, what if we only work 4 days a week, so we're only doing 16 days. I don't think the DEP's plan was to try to skirt this this idea. So I think it's best practices. If you know that you're going to be on these sites and need to do digging of these contaminated soils, then you really should be implementing PAM. Activities, again, with the potential to generate air emissions that may impact your offsite receptors. Again, that's my interpretation of it. Whether it hits that 20 working day period or not, I think you have to use your best judgment here. It's to be followed during all remedial activities on site, disturbing of soils. You really want to make sure that you're implementing this and collecting data. This data could be very valuable to you down the road if you get any sort of complaints from your offsite receptors. It's better to have the data and not need it than to need the data and not have it. So we've had instances where people asked for it and it was after the fact, but unfortunately at that point we don't, you're not going to have any readings to prove that you were below these levels. The confirmatory sampling is done to show how effective the real-time monitoring is at capturing these surrogates. The real-time stations are going to provide you these values, but the confirmatory sampling is going to give you exactly what's in the particles that you're capturing. You need to have a plan for handling the exceedances as we went through in step 6. So what to do if you get and receive these higher levels, what are your actions on site? And then always use best practices is another key takeaway for us. All right, so for the people that had some questions about the calculating averages and those kinds of things, some of the services that Triumvirate does offer are we can develop the PAM plan, the perimeter air monitoring plan, including those calculating of the HBTV and response levels. That's a service that we offer. We can provide that for you if you don't feel comfortable doing it. Based on those calculations, we can also recommend an analytical sampling method that would meet your project goals. Obviously, this is new to a lot of people. We've been doing this at Triumvirate for quite a while now, so we're very comfortable with it. And if you have any questions, we're here to help and happy to help. We also offer rental of the PAM stations. We call it Greenlight. That's our system that we developed dating back to that Hex Chrome site in Jersey City back in 2005. Back then we were using 900 megahertz radios, and the technology has come a long way since then. We're now using cell technology and cloud-based servers to provide that data to you. We can also use a combination of the stationary and the mobile stations. So that's an important piece. Maybe you want to set up one that you know is going to be fixed, but then shift a few of the other ones around. Here at Triumvirate, we also offer the complete package where we can provide you with the air monitoring technician that manages the day-to-day entire process of the PAM program. So that kind of puts it as a third party. We take all of the ownership of it. We're responsible for your daily reporting and working with the construction team on site to let them know if there's elevated readings and how to handle that. All right, we've made it to the Q&A session at this point. If anyone has any questions, I think you can enter them into the chat. Or if there were, I think there were some questions submitted a little bit earlier.
Yes. Thank you for a great discussion about the importance of New Jersey Department of Environmental Protection's air perimeter monitoring guidelines and how to comply with them to improve safety and to maintain successful operations in the Garden State. And as you mentioned, we have come to our Q&A segment, and I, for one, am excited to hear the audience's questions. And as you mentioned, we do have some previously submitted ones earlier in the session. And the first one is, when should you do baseline testing prior to a big construction project? And that includes outside digging in the dirt.
Baseline should be done prior to any of the work starting on site. So before you get the equipment, the machinery there, before you start doing anything intrusive on site, you really should step in, get these baseline numbers, collect them. Typically, I would say we, see them for 3 days is a common number prior to any work activities on site. 3 days of collecting data for the full duration of your workday, analytical sampling along with the real-time readings. But I would say, certainly before the work starts is your most critical time.
Excellent. Another question. Typically, how many stations will be deployed at these types of sites?
That's a great question, but it really depends on the size of the project. There's a lot of these sites that get cleaned up that are relatively small. So 2 stations should be sufficient, 1 upwind, 1 downwind, that you would just move around as the day goes. We've seen sites that are much, much bigger where we have 8 or 12 stations set up at them. It really depends on the size of your project. A nice size project, I would say a minimum number is probably 4, as long as you're covering those offsite receptors. If there are more offsite receptors, you may need to saturate that area with some extra air monitoring stations. But for the most part, you always want to at least have 2 stations, 1 upwind, 1 downwind. And a lot of the times we'll see, we'll get sites that have 4 stations set up in each of the cardinal directions, and they'll run for the duration of the workday. Technicians will go out there, they'll service the instruments, they power them on and get them up and running. But really it depends on your project site and what offsite receptors you have around you.
Excellent, thanks. And I want to remind the audience, we have a few moments left, and this is your opportunity to get a world-class expert's opinion. So the next question is multi-pronged, and I'll break it up so that it's a little easier to digest. First question is, who is qualified to do the measurements?
As the document states, an air monitoring technician who's got some experience with the equipment, who understands the purpose of doing these readings and collecting this data, understands how the instrumentation works, understands what the readings would mean. All of those things are critical as to who you would put out there, which is why they really have made a point to have a dedicated air monitoring technician on site.
Thank you. And the next component of the question is, who is qualified to interpret the results that are generated?
Very often you may need to bring in a CIH, a certified industrial hygienist, if you end up with some elevated readings. You may also need to bring in a toxicologist, depending on what kind of levels you're dealing with. As long as things are kept under those response levels, though, your air monitoring technician should have a pretty good understanding of what's happening on site and what those levels would mean.
And the final component is, can you share ideas about pinpointing testing sites both in external and in internal environments?
That one's a little confusing, but again, you really want to set them up around the sensitive receptors and making sure that they're not going to be impacted by the work that's happening on site. You want to set it up between the work zone and the perimeter of the project. But yeah, I'm not really sure. Can you read that one again, Mark?
Yeah,
Maybe
sure. Be happy to.
Something.
Do you have ideas about pinpointing the testing sites and that can be in an external or an internal environment.
Yeah, I mean, a lot of the times too, once you've identified prior to any of this PAM being implemented, you've already done some preliminary analysis of the site. So if you would know where your hotspots are, where your contamination has spread. By the time we're getting there doing the PAM, it's already typically been laid out by the engineers on site and the environmental companies.
Great. We have another multi-pronged question. It's a bit technical and it may require some follow-up, but the first half of it I will share with you, and if you care to take a venture to answer it, I'll leave it to you. And the question is, before you recommend a PAM, do you calculate the total dust concentration needed to present for a sustainable, appropriate averaging period to reach the exposure limit of concern? Now, I can repeat that if it is complex, and again, I leave it up to you if you feel if you want to take a crack at that one.
All right, just give me a second. My my computer's starting to die here. I want to get this plugged in so I don't lose anybody.
Sure.
Okay. Let's see.
And just wait, and hopefully Matt will not leave us, particularly as we're on the cusp of an interesting question. And Matt, I believe you're frozen out, and we are coming to the hour. So I suspect we may have to leave that question to be answered after the event. And we're at 2:57. So I guess we'll simply thank Matt and thank everyone else for attending. Our event was New Jersey Department of Environment Protection Air Monitoring for Engineers, What You Need to Do. Now, as I mentioned earlier, you will receive an email with a copy of the presentation and recording. You will also receive a link to a short survey. We appreciate your webinar feedback on and any ideas you have for future topics. Thanks for your participation, and we look forward to seeing you at upcoming events.